Hello friends, welcome to engineering tutorial. So here is another question on error analysis. So the question is, the open loop transfer function of a unity feedback system is given by Gs is equal to 5 by S into S plus 1 into S plus 10, and we have to find out the steady state error for unit step, ramp and parabolic inputs. So again, the important thing first to identify in the question that it is a unity feedback system. Only then the error constant method is applicable. Then the transfer function, open loop transfer function, that is this. Then the nature of inputs, unit step, unit ramp and unit parabolic. Okay, so here we'll proceed step by step. First, the steady state error for step input. So when step input comes into play, here it means it is equal to 1. Okay, RT is equal to 1 or RT is equal to UT, that is. So in that case, the value of A which we use in the error constant method, that is equal to 1. This is very important. Then we have to determine the position error coefficient or step error coefficient, whatever you wish to call it. Okay, that we have to find out, which is equal to Kp, that is equal to limit s tends to 0 Gs. So here it is limit s tends to 0, we'll put this value of Gs, that is 5 by s into s plus 1 into s plus 10. Okay, this. So we'll simply substitute s with 0, that will be 5 by 0 into 0 plus 1 into 0 plus 10. So it is 5 by 0 into 1 into 10. So it is 5 by 0, which is equal to infinity. Okay, so here the step error coefficient or the position error coefficient is equal to infinity. We know that the steady state error due to step input is given by A by 1 plus Kp. Here A is equal to 1 because the unit step input is used. 1 by 1 plus Kp value is equal to infinity, which is equal to 1 by infinity, that is equal to 0. Infinity plus 1 is the same, is a very high value, so that we call infinity. So 1 by infinity, here it is equal to 0. The steady state error due to step input is equal to 0. Next is ramp input, steady state error due to unit ramp input. Okay, so here we have to determine the velocity or ramp error coefficient. Kv, which is limit s tends to 0 s Gs. So here limit s tends to 0, s multiplied with here 5 by s into s plus 1 into s plus 10. So ss gets cancelled, so it is simply limit s tends to 0, 5 by s plus 1 into s plus 10. So we'll substitute 0 here, so it is 5 by 0 plus 1 into 0 plus 10. So it is equal to 5 by 1 into 10, which is equal to 5 by 10, which is equal to 1 by 2, which is equal to 0.5. So here the velocity error coefficient Kv is equal to 0.5. Now we know, we have derived in the introductory video, the steady state error due to ramp input is equal to A by kV. Here it is unit ramp, so that's why the value of A is equal to 1, kV is 0.5, so that is equal to 2. The value is equal to 2. The steady state error value equals to 2. This. Okay, so steady state error due to ramp input is equal to 2. Next, for parabolic input, the steady state error due to parabolic input. Unit parabolic input here. So for that, first we have to determine the parabolic or acceleration error coefficient. Okay, acceleration or parabolic error coefficient. That is equal to Ka limit s tends to 0 s square gs, which is equal to limit s tends to 0 s square into 5 by 0, it is s plus 1 into s plus 10, s into s plus 1 into s plus 10. So here it will be s here in the numerator, then we'll substitute every s with 0, so it will be equal to 0 into 5 by 0 plus 1 into 0 plus 10. So that will be equal to 0 by 1 into 10, which is equal to 0 by 10 is equal to 0. Okay, so it is 0. So here the acceleration error constant is equal to 0. Now steady state error due to parabolic input is equal to A by Ka. Here it is unit parabolic, so A is equal to 1, K is equal to 0 we have calculated, so it is equal to infinity. Okay, so here the steady state error due to parabolic input is equal to infinity. This. Okay, so here again, while approaching any question related to error analysis, the first thing which you have to be careful about is to make sure that it has been mentioned in the question that it is a unity feedback system, feedback path gain Hs is equal to 1. Then determine the open loop transfer function. Okay, always be careful that only the open loop transfer function is applicable for determining these error constants. So you have to be very careful about that. Then find out what type of inputs are being applied, what is the nature of such inputs, okay, whether it is unit step or simply step, or what is the value of that step constant. So depending on that, you have to figure out whether it is step, ramp or parabolic. Then for each input type you have to find out the error coefficient. Okay, step or position for step error, step input, then velocity coefficient for ramp, then acceleration error coefficient for parabolic. Then you have to simply remember the formula. For step it is A by 1 plus Kp, for ramp it is A by Kv, for parabolic it is A by Ka. Simply put the value, get the result. So also one thing you have to be careful about is how you put the value of zeros, when you substitute 0, how you do it. Most of the times mistakes happen here and you will get the wrong result of the error coefficient, so that will also give you the wrong answer. So be very careful about that also. So remaining is just remembering the formulas and putting the values. Okay, it is only that. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.